respected Principal Dr. Sylvanus Lamare, the IQAC coordinator of the St. Edmund's College, Shillong, Brother Simon Coelho, Secretary of the St. Edmund's College. My dear students, I stand here on behalf of Department of Electronics, St. Edmund's College to introduce a webinar on the fundamentals of plasma, going to be delivered by one of our very bright student who is presently pursuing her PhD in the Institute of Plasma Physics, Ms. Rupali Paul. We have amongst us Brother Simon Coelho, the coordinator IQAC. It is really indeed an inspiration that he is present in this webinar. So I do hereby request him to deliver a speech before we start the lecture.
Respected Principal and Vice Principal, Head of the Department of Electronics, D. Chowdhury sir, all the faculty in the department and dear students, it is indeed an education for each of you to get an overview of plasma and its role in electronics. The possibilities it holds are endless. This is an opening field. The students of St. Edmund's are very fortunate to have Miss Rupali Paul, who is currently pursuing her PhD and is an authority in plasma technology. Being from this college, she will, I'm sure, be an inspiration to each of you students to pursue your dreams with determination and hard work. Irrespective of talent, the hard work and bent for research has to be there. If you are going to break new grounds and be trendsetters, I'm sure each of you wants to be a trendsetter. I wish the resource person and all the participants the very best and every success for this webinar, which is being done in collaboration with IQAC St. Edmund's. God bless you all, Brother Simon.
Thank you, brother. Your words are of great inspiration to us to do this type of program in the near future also. Thank you. My dear student, that when we talk about different states, we are very well known about the very three states of a matter, which is solid, liquid and gases. But beside that, there are states which we need to be aware. One of the other state is the plasma state. So to brief it, we can say that a gas which is subjected to a very high electromagnetic field or very high heating, which will result into ionizing the gases, and it will be in a very, very high conductive state. Rupali, as she is pursuing her degree, PhD degree in the field of plasma, she is going to give you a lecture which we feel will be a very, very beneficiary to our students on the fundamentals of the plasma. So I request my student to take the advantage of this lecture, and if there are any questions, any discussions, they should come and they should discourse their confusions in the discussion period after the lecture is over. So now the lecture is going to be delivered by Rupali Paul.
Hello everyone, my name is Rupali. Let me give you a brief introduction about myself. I am currently pursuing my research career at Center of Plasma Physics, Institute for Plasma Research at Sonapur. So where should I begin with? I am an Edmundian like most of you here. I joined St. Edmund's College in the year 2011 for my bachelor's degree. I joined the Department of Physics, and electronics and mathematics were a part of my curriculum. I completed my graduation in the year 2014 and joined NIHO for my master's, which I completed in 2016. So for a brief period of time, I had the opportunity to serve my alma mater as a part of the teaching faculty. I joined the college in the year 2016, but now the roles were reversed. I enjoyed and felt honored to serve my alma mater. I joined the institute for pursuing my research career in the year 2018. So before starting with the presentation, I would like to thank a few people who I'm indebted to. First and foremost, Dr. Sylvanus Lamare, the principal of St. Edmund's College, Brother Simon Coelho, IQAC coordinator, Brother Naj Narona, Secretary of the governing body, and most importantly, my teachers of the electronics department, for giving me this opportunity to address and interact with my fellow Edmondians. I'm highly honored and thankful for that. Dear students, I would like to tell you that you are at the right place with the right people. You have chosen St. Edmunds for your pursuing your bachelor's degree here. It will not only provide you with academic brilliance, enhance your academic brilliance, but also by the end of your tenure here, you will be a better version of yourself. Department of Electronics is well equipped and the teachers are extremely generous and are always there for you, any help required. I can actually tell you from my experience here that the in-hand workshops and the projects given to us from the department, we were taught to build, to assemble circuits from scratch, that is from the breadboard to the PVC, to the final output on the PVC. This experience has really helped me in my experiments here in the labs, in my research career, because we need to have built some in-house, small in-house circuits we need to assemble. So this in-hand experience had really helped me. So I'm really thankful to all the teachers for such a wonderful experience. So with further ado, let us now jump into the presentation. So let us begin the presentation. So let me begin without further giving any more elaborate talk, let me just give you a brief overview of what plasma actually is. I think most of you might be aware or might not be aware. So just let me give you a brief insight of what actually it is. So what plasma is? You must all have heard about solid, liquid and gases being the states of matter. But there is another state of matter. The fourth state of matter is nothing but plasma. So what is the basic difference between solid, liquid and gas? It is nothing but the strength with which the molecules hold, the bond with which the molecules are held with, the constituent particles are held with. For solid, that bond is quite strong. That is the reason they always held, they have a definite shape. In liquids, it's relatively weak, and in gas, it's almost, we can almost say it's almost absent. So what happens is when we heat a solid or liquid, it is actually what we are breaking the bonds. We are giving the molecules enough heat so that the molecules can overcome that, the bond energy that they have, they can overcome that, and the binding force is broken, which leads to a phase transition. Solid becomes liquid, liquid becomes gas, and then what happens is this molecular gas is then provided with enough energy. We heat the gas in such a manner that it can dissociate. What are molecules made of? Basically ions and electrons. So these molecules will get enough energy in the form of heat, and then they'll dissociate into individual constituents and collide, and there will be collision between them, and this gas then becomes plasma. But this is not possible only when the temperature is gradually increased, and in the a layman's thing, I can tell you, all of you know what is 1 eV. It's electron volt. It's energy, yes or no? So in plasma, we have 1 eV is considered to be 11,600 degree Kelvin. So you can imagine the amount of heat it generates. So plasma, for forming plasma, you need a lot of heat. So as I've already mentioned that 99% of our entire universe is made out of plasma. Most of us get confused with blood plasma. The ones who've studied biology in their secondary and higher secondary classes all of us have always heard about blood plasma. So why do I say most people will ask me, how is your plasma different from blood plasma? The word has been taken from there because our blood plasma and all have this coagulation system is there, due to which it means that it can be molded. So the fourth state of matter, the constituent particles, they also stay together, move like a fluid. That is why the term plasma has been given to them. It was first used by Tongs and Langmuir in 1929. They were doing some sort of experiment where arc-like. Have you seen these welding machines and all that, where you get the sparks? Those are nothing but plasma. So some sort of thing came out, due to which this term was given by them in 1929.
So these are some of the naturally occurring plasmas. Sun, stars, all of us know sun is a great source of energy. So it is a form of a plasma. Their fusion reactions occur, and then we get a sort of energy. Reactions occur, and then the energy comes out, and that energy is we the earth is actually living on that. Then we have the northern lights, the aurora borealis. You all must have seen these pictures in movies and all that, where people actually have the fantasy to actually go and see them. They are nothing but also plasma. Then comet, the tail of the comet is also plasma. These are basically these comets and Jupiter rings. They are basically dusty plasmas. Now, dusty plasma, do not confuse it with like, dust in a plasma is not the normal dust you see. It's not. Is any foreign object which is present in plasma is referred to as dust in a plasma. And dusty plasma is some sort of dust particles which are maybe metallic, maybe non-metallic, maybe insulating kind of an object. So they form as another class of plasmas which are known as dusty plasmas. So comets and Jupiter rings are also a form of dusty plasmas. So some of the artificial plasmas are plasma globe, arc, as you can see the picture there, then the arcs from arc welders, and then sparks of the static electricity, as I've told you, the arcs of the welders. When you see, have you seen any? I guess you all must have seen these people who work in the garages and all that. When they work with some sort of welding machine, a spark of light comes out. That is nothing but plasma. Then sparks from static electricity, that is also plasma. Now, these are all the other forms of plasma. But how do we study that? For that, we need to have a clear understanding to make them in lab. So laboratory plasmas are classified in two forms. One is cold plasmas, another is hot plasmas. Now, what are cold plasmas? I've already given you a definition that plasmas are nothing but it consists of electrons, ions, and the neutral gas atoms, which have not been ionized to form plasma. So the temperature of the electrons, ions, and gas will be the temperatures will be different. So when temperature of the electrons are much greater than the ions and greater than the gas molecule, neutral gas molecules, such plasmas are referred to as cold plasmas. When all of the three are in equilibrium with each other, I mean of the same, almost same energy level, such plasmas are known as thermal plasmas. This is a way of classifying them in temperature, in a temperatures way we can classify them. Another way of classifying this hot plasmas and cold plasmas are when a plasma is fully ionized. I hope everybody is aware with ionization, like when these electrons hit a neutral gas atom, they dissociate. After dissociation, what happens is because of collision, they'll dissociate, they'll form constituent particles, like constituent particles meaning ions and electrons. When a gas is fully ionized, that means there are negligible amount of neutral gas atom. Such plasmas are known as hot plasmas. And a partially ionized gas is referred to as cold plasmas, where a portion of neutral gas atom is yet to be ionized and the process is like it keeps on, the process is still on. Such plasmas are referred to as cold plasmas. Now, before going to applications, I would like to say how we form plasmas in the lab. So, I think all of you are aware of thermionic emission. So, one method of producing plasmas are by thermionic emission. What we do is we have a cylindrical chamber, closed chamber, where we make the chamber in vacuum. That means we take out the unnecessary, the air present in the system, we through these pumps. I think you must have seen these suction pumps and all that. So we have some sort of air pumps through which you take out the air from the system and keep it at vacuum. So you have rotary pump, you have diffusion pump, all sorts of pumps are used to make the system in vacuum. Then we feed in the gas, like whatever gas plasmas we want, because different gases will have different plasma color. The blue plasmas are in low pressure plasma, in low temperature plasmas, like mean cold plasma, hydrogen plasma, you will have argon plasma. So depending upon what plasma you want, you feed in the gas. Then what you do is you start heating a filament. Yes, you start heating a filament, and when you start heating a filament, thermionic emission starts. So these thermionic emissions will emit electrons, because so these electrons which come out of the filaments do not have enough energy to ionize the gas. So what we do is we provide it with another voltage which accelerates the electrons, and it collides with the neutral gas atom so that it dissociates into its constituent particles and plasma is formed. So this is one method, one such method of producing plasmas. There are other methods as well, but this is the most the method, this is known as filamentary discharge or hot cathode discharge method of producing plasmas. So this is how plasma is formed, and where it is found I've already told you. Next, let me tell you where it is, the applications of plasmas, which I think is most relevant for you, as you've already seen this slide. So plasma etching is a most and is another great field of research. So it is mostly involved in fabrication of the integrated circuits, ICs, which you are going to use it in your, whether be practicals or anything, you're going to study about it in details. So those integrated circuits, in semiconductor industry, plasma has a wide range of applications, such as making of MOSFET and or PN junction diode. All these sort of these semiconductor materials are now actually, people in these industries use plasma so that the process is quite efficient and easily done. So what you have in a PN junction diode, you have a P section, P type, and you have an N type. You dope, you have a material, and you uh, imprint impurities in it. That can be done using plasma. So the germanium or the silicon material, the plasma is whatever type of if you need a P type, that means you need to have more number of positive charge in it. So what you do, you increase the positive charge on it through plasma. You interact plasma with the plasma interacts with the substance and increases the positive charge, so that it becomes a p-type semiconductor. Then you have a system where you want to increase the number of holes, I mean electrons. So plasma can be used to do such processes, and it is very efficient. So plasma etching is one of the widely widely used application of plasma. Next is plasma nitriding. Now, this is also another plasma surface interaction, where the plasma interacts with the surface and it changes the properties of the surface. So, what is plasma nitriding? As the word you can see, nitriding has something to do with nitrogen. So, the plasma increases the hardening surface. It hardens the surface by impinging nitrogen into the component surface. So it is basically to increase the surface life of the component, metallic component. So because sometimes what happens, you have a system, you have a material which you want to make something, but due to some of its intrinsic properties, it is not being able to behave it in some certain manner. So if you have some sort of impurity like nitrogen and all that, it will have a better service life. So that can be done using plasma nitriding. So plasma interacts with the surface, infuses nitrogen inside it, and increases the service life. Another such process is plasma carburizing, where you increase the carbon content in the steel and it hardens the surface. One of the greatest fusion reactions which is actually going to take place is this experiment, is an experimental reactor. It's a reactor is basically a device which has been made, which is artificially being made for the reactions to take place. So ITER is one such experimental reactor. It is known as International Thermonuclear Experimental Reactor. It is the greatest initiative ever taken by humans. It is an initiative taken by 35 nations across the world. It is being built up in southern France, Cadarache, and is going to It is the world's largest magnetic confinement fusion device. Now, what you all might have a question that what magnetic confinement fusion device is. It is basically plasma is nothing but it's a composition of charged particles, yes or no, which are have very high temperature. One electron, I mean, the temperature in plasma is generally expressed in terms of EV, electron volt unit of energy. So 1 EV is 11,600 degree Kelvin, which I've already mentioned earlier. That so you can imagine the amount of heat it has. So it is very difficult to confine it in a place normally using electric field, because if whatever substance it comes in contact with, it's definitely going to melt it down. So we use magnetic field to confine them. So what does magnetic field do is it confines these charged particles in a region, and such devices are known as tokamaks. So nuclear this ITER, International Thermonuclear Experimental Reactor, is also another tokamak, where it is going to in I mean, sustain the fusion reactions. The fusion reactions are going to take place inside the nuclear reactor, and it is going to provide us with energy. And it is also another version of tokamak. So, what will actually ITER do? I've already told you that it is going to replicate the entire reactions which are actually taking place in suns and stars, and it is going to give you us amount I mean the energy to clean green energy, which is very important now. So it is also sometimes referred to as international artificial sun, because we know, like in the year 2020 has taught us a lot. Being be it pandemic, staying in lockdown, we have seen how the global emissions cause global warming. The carbon content in the atmosphere has created so much of havoc on all of us that now we all must realize that clean green energy is the only way to sustain to give our future generations a better place to live in, where we'll have less climate change, temperatures will be lower, we'll have all animals and everybody will have a coexisting lifestyle. I mean, life system here. So the importance of fusion energy is understood by all, I guess, by now. India is also one of the I mean, the member country of this, along with the other 35 nations, which are the other members of this member countries are European Union, Japan, Korea, Russia, and the United States. So ITER India was also an important division of, is another division of my parent institute, Institute of Plasma Research. The scientists there had helped in developing one of the important components. I mean, components of ITER, and I think it came in the news as well. Prime Minister Modi had also congratulated the scientists for having been able to deliver the components in southern France, and now they've started assembling it as well. And it is actually, it was supposed to be assembled in 2020. I mean this year, but you can understand it's a huge. This is the place which is in southern France. It's a huge project. So there are definitely many challenges which we had to undergo. They had to undergo. So the process was delayed, and it is supposed to be operational by 2030. There, not only on the physics point of view, there are a lot of scores, but engineering wise, it was of a great challenge for them to assemble each and every component at right place at the right I mean location, because it is such a huge area that you cannot go and do the work by yourself. So it has to be remote sensing, where again electronics plays a very important role. So it is a huge project which have been taken up. So definitely there are some challenges which they are going through, and I believe they will be soon be able to overcome that. And the first plasma is supposed to be formed by 2030, and the amount of power it is going to generate is about 500 megawatt of power it is going to deliver. So it is a huge amount of power which later will be commercialized, where it will be given for the normal, I mean the common people to take up the, I mean, it will be another alternative energy source. So believe I was able to give you some sort of insight to what the plasma world is. Thank you for patiently listening to me. And I would request the teachers to bring the students to our institute at Sonapur so that you all can see how it is being made, plasma is being made, and how we are actually doing some sort of experiments in the lab, and then you have an insight, and maybe you might have a greater future in the field of plasmas. So with that, I would thank everyone and stay safe. And thank you for giving me this opportunity. I would like to thank the teachers once again for giving me this opportunity. Thank you.
As we have come to the end of the interesting talk on plasma by Rupali, I do take the privilege to propose the vote of thanks. At the very onset, let me first thank Rupali for giving an interesting and well-presented talk. It was very informative and it clearly shows the hard work gone into it for the preparation. I thank her for giving us time out of her busy schedule. I know how much of our valuable time has gone into it. Next, I would like to thank our principal for his encouragement and support, without which it would have been difficult for us to conduct such a program. Our thank and gratitude also goes to Brother Coelho, Coordinator IQAC. He is a big support and gave us a free hand to conduct this program. Next, let me thank member of the illustrious government for working as a team program and to make the program a success. Thank you, Bhawan, for conducting and coming out with a well-edited and well-presentable video. Showman for conducting the whole program with ease. Kishore and Hemant for the help behind the scene. I apologize if I have forgotten to thank some. It is unintentional. With this, I conclude my vote of thanks. So with this, the program ends. Thank you, Rupali.